maximum tractive effort and reactions for different drives. So we have seen the expression for acceleration, reaction force at the front and rear. Okay. And for all-wheel drive with the third differential and without the third differential, we have seen. Now we are going to discuss about prediction of vehicle performance. Okay. So today we will be starting what prediction of vehicle performance. So what is vehicle performance? That is when you are going to design the vehicle, no, you have to understand what are the requirements for the vehicle, what type of road it is going to driven, and what should be by engine power, how to design the engine, and what are the geometry parameters. That is a wheelbase, I height of the CG from the ground, and other things. Okay. So first of all, uh, main thing in vehicle performance is whether you are going to keep whatever engine. I will be bothering about what is the force available between tire and road. Okay. So what is the force available between tire and road? That is the tractive force. Okay. So this tractive force is the main thing that the engine is going to provide. So this tractive force only going to propel my vehicle. Okay. So for obtaining that tractive force only, we have to choose the engine. Okay. So already we have discussed what is attractive force or tractive effort. It is a force available at contact between tire and road. Okay, it is a force available at contact between tire and road. And already we have discussed what is traction. That is in VDDC. I explained you what is a traction. There is a normally will be having engine at the front and power will be delivered to the rear wheels. Okay, power will be delivered to the rear wheels. Okay, so the ability of the rear wheels to transmit this effort without slipping. Okay, that is the rear wheel should get the power from the engine and without any loss it should transmit. Okay, so that is known as traction. So always my tractive effort will be less than traction. Why no? Traction is the ideal case. That is we are assuming no slipping. That is we are getting full power from the engine. That power is transmitted. That is used for propelling. Whereas tractive effort will be it's a force available at the contact between tire and road. So due to transmission losses and other things, my tractive effort will be always less than what traction. Okay. So you might have understood that engine torque, the expression for engine torque, that is you know the formula, power is equal to 2 pi nt by 60. In that power, you will be getting what 60 watt, no? Please wait. You are able to see the cursor, ma? Arrow? Anyone of you please confirm?
No, sir.
You are able to see the cursor?
Uh, yes, sir.
Cursor.
But
Cursor. That is
தெரியுது
now I
தெரியுது
am
sir.
keeping near where
நடுவுல மறைஞ்சிருக்கு.
இந்த arrow தெரிஞ்சா ஈஸியா இருக்கும். நடுவில் இந்த வியூ நல்லா இருக்கு பாத்தீங்களா? அந்த வியூவோட இந்த வியூல வந்து நல்லா இருக்கு. இந்த ஃபுல் ஸ்கிரீன் வியூல வச்சு ப்ரெசென்ட் பண்ணும்போது லுக்கிங் குட் உங்களுக்கு கிளாரிட்டி கிடைக்கும். இப்போ நான் அந்த கர்சர் மூவ் பண்றேன் பாத்தீங்களா? அது வந்து இப்ப தெரியுதா? நான் ஒரு இடத்துல வச்சிருக்கிறேன். எந்த இடத்துல வச்சிருக்கேன்?
UQ3 போட்டிருக்கீங்க சார். யூனிவர்சிட்டி வெர்ஷன் 3.
வெரி குட். போதும். அது தெரிஞ்சா போதும் எனக்கு. ஏன்னா நடத்தும் போது கோஆர்டினேட் பண்றதுக்கு ஈஸியா இருக்கும். ஓகே. பாயிண்டர் அதான் பாயிண்டர் கர்சர் எல்லாமே ஒண்ணுதானே?
பாயிண்ட் பண்ற இடம் நல்லா தெரியும் சார். ஆனா மூவ் ஆகும்போது இப்போ ஒரு இடத்த நீங்க சுத்தி சுத்தி காமிக்கணும்னா அப்ப தெரியலன்ற சார்.
சரி அது பிரச்சனை இல்லை. அப்ப நான் இது மட்டும் நான் சொல்றேன் போதும். ஓகேயா? சரி. See, already we know that is a power is equal to 2 pi nt by 60, where you will be getting the power as what? Watt. Okay. Whereas when you need a kilowatt, no, you will be putting what? P is equal to 2 pi nt by 60,000. So that you will be getting 60 watt. Okay. So from this you can calculate the engine torque. Okay. So whatever power I am going to design for the engine, from that I can calculate engine torque. So you'll be writing what? 60,000. Assume that power of the engine is given in kilowatt. Okay, so this power is a brake power. You should not confuse with indicated power. So whatever I am putting a power, no, that is I am using the formula 2 pi nt by 60. Otherwise 2 pi nt by 60,000. That power is what? Brake power. Okay, so I'll be writing engine torque Te is equal to 60,000 Pe by 2 pi n, where n is what? Engine speed, that is in RPM, and P is engine power, that is a brake power. The unit will be a kilowatt. So when you are going to substitute this now, since I am having 60,000, the kilowatt will be converted into watt, and we are having a speed, so everything will 60 we are putting, so it will be nullified, and you'll be getting a unit called a Newton meter. Okay, so you'll be getting a unit Newton meter. Okay. So now, see, you are getting a torque. Okay, that is from the engine. You are getting the torque. Now, I am going to find what is the torque available at the rear wheels. See, I am putting a TE. See TE. The engine torque is the torque that is available at the crankshaft, output shaft, or flywheel. Okay, crankshaft or flywheel, like that I can say. But the road wheel, what is the torque I am going to add? There is a torque at rear wheel. Say the power is delivered to the rear wheel. Transmission efficiency, you can see there is a transmission efficiency I have to put, and you have to put the gear ratio and axle ratio. How far it's getting multiplied. Okay, so the transmission efficiency will reduce the torque, whereas the speed reduction devices, no, that is you can see GR stands for gear ratio and AR stands for axle ratio, final drive ratio. Okay, so I will be having a gears. So when I'm going to provide a speed reduction, I can increase my torque. That is, I can multiply my torque. And final drive, always there will be what? A speed reduction. Okay, you will be having an axle ratio, and we are having transmission losses. Some torque will be getting lost, so that will be accounted by transmission efficiency. So I'll be writing like this: G, capital G is equal to gear ratio multiplied by axle ratio. Okay, so G is equal to transmission efficiency into engine torque. Now you know that force is torque is equal to force into radius. Okay, torque is equal to force into radius. So I can find the force. Tractive effort is equal to tractive torque divided by radius. Okay, so torque is equal to force into radius. So force is equal to what? Torque by radius. Okay, so in that torque, no, I am putting this term G, that is transmission efficiency, engine torque, similar to VDDC. Everything is similar to VDDC. Okay, so instead of TW, I am putting what? TE, that is engine torque, G, transmission efficiency divided by R. So note on this formula. Whenever you know engine torque, just like that, you should not divide by R for finding out the tractive force. Okay, see what is the concept? No, uh, when you are going to find T by R, there are multiple factors which is going to influence the tractive force. That is, a gear ratio will influence, and transmission efficiency will influence. Okay, so transmission efficiency will decrease the tractive effort, whereas the gear ratio will increase the tractive effort. Okay, so you please note down this formula. Tractive effort F is equal to engine torque multiplied by gear ratio multiplied by transmission efficiency divided by R, that is the radius of the wheel. And TE stands for mean engine torque in Newton meter. That is, I am using T suffix small e or T suffix capital E, whatever it may be. It is mean engine torque in Newton meter. Okay. So what you are going to do? You please write this formula. I will be giving 1 minute time. Please write this formula. All are requested to write this formula. Okay, we will go to the next slide. So now see, T stands for mean engine torque in Newton meter, and this one will be overall transmission efficiency. And we are saying G is ratio. That is capital G is a gear ratio that includes both gearbox ratio as well as axle ratio. That is back axle ratio. R is radius of tire. N is RPM of the crankshaft. Now see, I am having tractive effort. Okay, from engine I am getting a power. That power is converted into torque, and that torque is converted into tractive force. Listen carefully. Engine, I am getting rotation power. The rotation power is transmitted as a torque, and torque is converted into tractive force. Okay, so whenever this tractive force, no F, is greater than R, that is a capital R. What happened? R is total resistance. That is, whenever you are traveling on the road, we'll be having a different resistance. One is a rolling resistance, and another one is a gradient resistance, then aerodynamic resistance. So when you are adding all the three resistance, you'll be having what? Total resistance. Already you have studied in VDDC. So resistance should be overcome by tractive force. When F is less than R, no, you can't propel the vehicle. When F is greater than R, then only you can propel the vehicle. So the excess of F compared to R will be used for acceleration. Okay. So when you are going to accelerate, what will happen? At one instant, my F will be equal to road resistance. That is the load. Okay. So the input will be equal to the load. So at the time, what will happen? My vehicle will be running at constant speed. Okay. So you can see the excess tractive effort when F is greater than R. I can say in two words: tractive force is more. Otherwise, I can say tractive effort is more. Okay. So this tractive effort, the excess tractive effort will be used for acceleration. That is, I can accelerate my vehicle. Otherwise, I can use it for climbing a hill. Otherwise, I can pull another vehicle. That is, I can use a drawbar and I can pull another vehicle. Okay. So this one you might have studied in EDVC. So it is very easy for you. The last class itself, I have told you that is the last sum. That is what is the relation between engine revolution and vehicle speed. You'll be putting what V is equal to pi d n by 60, and D you put as 2R. Then always this speed will not be available. The speed will be reduced by gear ratio. Okay. So now see 2 pi r n G60. Now convert into kilometer per hour. Okay. That is a meter. When you want to convert into kilometer, divide it by 1000. And second, when you are have to divide, when you have to convert into hour, divide it by 3600. Okay. So in numerator 3600, denominator 1000. So now you can see I'm going to keep n by v. That is, I will bring the v here and I will take all the terms to the right hand side. G into 60 into 1000 divided by 2 pi r into 3600. So what I'm getting 2.65 G by R. So now it's so you please recap the formula and write down. That is what is the relation between linear speed and rotational speed. Okay. In other words, I can ask what is the relation between linear speed and rotational speed. Linear speed is V or rotational speed is N. So N by V is equal to 2.65 G by R. Okay. So note down this formula. Okay, we'll go to the next one. That is, we are going to discuss about effective weight. That is, when the vehicle at rest, no, we'll be having a weight called static weight. When the vehicle is going to be accelerated or something like that, vehicle is going to be in motion, we'll be having the weight changes. The weight of the vehicle will be changed. Okay, so the weight may be increased due to dynamic forces. So what we will be say, no, that is we will say as effective weight. Okay, why no? The rotating parts are getting accelerated. That will increase the weight W to WE. So in this case, how to find the surplus or excess power? No, that is always power is equal to force into velocity. Okay, listen carefully. Power is equal to force into velocity. Force for a vehicle, mass into acceleration. Okay, mass is what? WE. Acceleration is F, and the velocity is V. Divided by 3600, will be having what? Kilowatt. Okay, so you please understand this expression. There is a here I am putting V will be in meter per second, and other terms it will be in kg. Okay, in the vehicle dynamics at VDDC, even though we are putting a word weight, no, it will be in kg only. Okay, when you are going to do a problem, you'll be able to understand that the surplus or excess power, force into velocity, force is mass into acceleration, that is the equivalent weight into F. Okay, so from this I can calculate F. Okay, so F is equal to, that is what, 1 by W. Okay, F is equal to 1 by WE. That is what is a surplus power? That is a tractive force minus what? Road resistance. Okay, so from this expression also I can calculate what is the maximum acceleration. Okay, so F is equal to 1 by WE, F minus R, capital F minus R. You note down this formula. Okay. So next, all the formulas are related to VDC only. That is, you are going to design the engine. That is, what is the engine power you are going to fix. So now, at first, you know what is the vehicle power. That is for producing the tractive force. What is the vehicle power? Okay, that is PV, and you have to consider this transmission losses. So whatever vehicle power is going to come, no, you have to increase that power for the engine power. Okay, it should be more. So you are dividing it by transmission efficiency, that is zero point 0.5 or zero point 0.6, so that the final power required will be greater. And already you might have studied in VDDC that vehicle power, it will be depending upon what? My road resistance, that is RV by 3600. So this and all already we have discussed in VDDC. That is, instead of a vehicle power, power is equal to force into velocity, that is R into V divided by 3600. Then only I will be getting what? Kilowatt. So from this expression, I can find what is road resistance. Okay. So from the vehicle power, I can cancel this transmission efficiency. Then R is equal to 3600 PV divided by B. Okay. So this is the road resistance. And once you are finding the required power, I can find the tractive force in this formula. Okay. So tractive force is nothing but what? The vehicle power multiplied by velocity. So we'll be putting PE, that is engine power multiplied by transmission efficiency. Okay, that is a power is equal to force into velocity. So force equal to power by velocity. Remember this concept. So I need force. So I have to divide the power by velocity. This 3600 and all for unit conversion. Okay. So power, actual power will be engine power multiplied by transmission efficiency. Then acceleration, 1 by equivalent weight, tractive force minus road resistance. Okay. So F is tractive effort, or I can use the word tractive force, where R is road resistance. Okay. So already you might have studied what is gradability. The last some, that is what is the maximum percentage of grade the vehicle can negotiate. Okay. So what is the slope the vehicle can climb? So that is called gradability. So you can put what surplus power. That is when you want to find what is the surplus power is available. Based on that only I can negotiate a grade. So that is equal to W into V by 100 into 3600. So gradability surplus power I can put like this. Okay, 100 by W. That is engine power multiplied by transmission efficiency minus PV 3600. That is vehicle power. And what is the engine power available? So this always you have to understand this will be equal to this for moving at constant speed. When I will be having excess power, no, that is when the engine power multiplied by transmission efficiency, that quantity will be more compared to vehicle power. That is the power required to propel, power required to overcome the road resistance. That will be less. So I am having what excess power from the engine. That is the concept. Okay. So when PE transmission efficiency multiplied by 3600 by V, I will be getting what tractive effort. And when PV is going to get multiplied by 3600 by V, I'll be getting what? Road resistance. Okay. So when you are comfortable with the last sum portion, it will be easy. Otherwise, you please go through the last sum notes, and I have included this also. Just go through the formula. That will be sufficient. Okay. Please understand the formula and study. So you are having what? Gradability is equal to 100 by W, tractive effort minus road resistance. Okay, so you copy this formula, gradability. And what is gradability? The maximum percentage grade which a vehicle can negotiate with full rated condition. Copy this formula. Yeah, in Google Meet, they have updated. Okay, now you're able to see a pointer, ma. New features are added, it seems. Good. Manikandan, you are able to see a pointer, red color dot.
Yes, sir.
Yeah. Thank you for your suggestion, ma. Okay, now you can see gradability is equal to 100 by W. That is, you'll be writing this, and tractive effort minus road resistance, same thing what you are going to write. Okay, already we have discussed in VDDC. Now the resistance, that is how this F will be equal to R. R is equal to road resistance. Okay, so when I am going to move in a grade, no, that is I am going to move in a slope. I will be having three resistance. One is a grade resistance, another one is a road resistance, and another one is aerodynamic resistance. Assume that I am moving in a grade at high speed, say 80 kilometer per hour or something like that. Then only I will be having what aerodynamic resistance. And normal speed itself we will be having what RR, that is a rolling resistance. Okay, so the total tractive force will be the summation of gradient resistance RR, that is rolling resistance, plus RA, that is aerodynamic resistance. Okay. Then drop or bull, already you know, that is I can use the excess power, not for acceleration or grade. I will be using for pulling the extra load. Okay, so for pulling the extra load, how much force available? That is called what? Maximum draw per pull. That is I will be using tractive effort minus road resistance. Okay, tractive effort minus road resistance, that is equal to F minus R. Okay, so that will be what? Drop per foot. Okay, and you have to understand that when we will be having a maximum surplus power, that is maximum surplus power will be available when you are driving at low gear. That is when you are taking the vehicle, no, that is initially you will be putting in first gear, so at the time only more torque will be there. Okay, that is you will be having more power in the sense, not in terms of speed, power in the sense torque. Okay, so more torque will be available. Okay, so that is called the maximum surplus power. Okay, so at low speed I will be having more tractive effort, so I will be driving the vehicle at first gear, so I will be having excess power that can be used for drop or pulling or hill climbing or acceleration. Okay. So when the maximum speed is reached, no, whatever power I am getting and whatever power I am required, when both are going to be equal, my I will reach the maximum speed. Further, I can't accelerate. Okay, that is once you are starting the vehicle in first gear, more resistance will be there. Once you are overcoming, no, the excess tractive effort will be used for accelerating, and you will be accelerating to a particular speed. Okay, uh, at that speed, what will happen? The power coming from the engine will be equal to the power required. That is the vehicle power. Okay. So beyond that, you can't increase the speed. Okay. Beyond that, you can't increase the speed, and you will be reaching a speed that is called maximum speed. The available power is equal to the required power. That is, I can say my tractive force will be equal to road resistance. So at this time, your vehicle will be running at constant speed. Okay, and desired road speed is there. Desired load speed means when you are going to have what part throttle operation. That is this one related to wide open throttle. There is a part throttle operation means you will not giving full acceleration. The throttle will be opened partially. So whatever the part total operation. So what is the problem with the second feature? No, we will be consuming more fuel. There is whatever power coming from the engine that will be consumed. Okay, but in from economy point of view, when you are going to operate in part throttle operation, for each curve, that is a gear one will be having one curve, gear two will be having the curve. So that curve will be intersecting with road resistance curve. Okay, so that speed will be the desired speed. You have to operate that speed in that gear. So what happens now? I will be just matching the road resistance. Okay, I will be consuming the less amount of fuel. Okay, that is a very important. You might have studied in Giri book. That is, you can see in Automotive Mechanics by N.K. Giri. He must have given different curves. Okay, you might have gone through. Okay, so now what is the available tractive effort will be tractive force minus total resistance. Okay, total resistance will be rolling resistance and aerodynamic resistance, assuming you are not driving on a gradient. Okay, now I am going to explain one problem. It is the most important problem. Okay, with that problem, then after that, this and all will be completing in next class. This and all easy only. Already you might have studied this. Yeah. So I will complete this problem and another one problem also I will complete. Okay. See, you are having a vehicle. Okay. The vehicle weight is about 21.24 kilonewton, and in that vehicle we are having four wheels. The four wheels as rolling radius, that is R. The vehicle weight is 21.24 kilonewton, and this is the problem taken from that is you are having a Aisler, no? There is automotive mechanics by Aisler. In that I have taken this problem. Okay. So in vehicle dynamics, whatever content I am going to give, no, it is a combination of articles referred from different books. Okay, so I am having a tailor-made notes. That is, I have referred some portion from N.K. Giri, some portion from Wong, some portion from Gillespie, and some portion from Eisler. So it is a combination. It is like a guide. Okay, by referring different books. So it, tailor-made notes. Okay, so from my perspective, I think this will be sufficient. Most of my students have used these notes and they got somewhat good marks and okay, so you, I advise you to refer these notes as a minimum requirement, and you can enhance your knowledge by referring other books also, standard books. Okay, so another book, Rajesh Rajamani, unit 2 tires. We are using what, Rajesh Rajamani. So that only I have compiled all the notes in a PPT and I have shared as a video so that everyone will be getting benefited. Okay. So that you can see now a vehicle weighs 21.24 kilonewton. We are having what, four wheels, and each wheel is having a rolling radius of about 33 centimeter, and we are having what, radius of gyration. What is the radius of gyration? That is when you are going to find the moment of inertia, no? That is mass moment of inertia. I is equal to what? Mk square. Okay. So I is equal to Mk square. We will be using what? This radius of gyration. Okay. So you have to understand this difference. See, you may think this one is 21 and this one is 24. You should not get confused. See, 21 kilonewton and this one is 244 Newton. Okay, so vehicle weight is 21 kilonewton and the wheel weight is 244 Newton. Okay, so my students are confused. Okay, this quantity is bigger. You have to see the unit. Okay, this one is Newton and this one is kilonewton. Okay, so the wheel weight is given. That is from that I can find the mass. Radius of gyration is given. So from that I can find what, I, moment of inertia. Okay. Now the engine develops a torque of 325 Newton meter. That is engine torque. So you have to note down this engine torque. Okay. The problem is bigger. It's not over. Now see the equivalent mass moment of inertia of parts rotating at engine speed. Okay. So whatever parts rotating, no, for that I have to consider what, inertia. For wheel, see, wheel is getting rotated. For finding the moment of inertia of the wheel, what I am having, the radius of gyration is given and weight of the wheel is given. So I can find mass moment of inertia of the wheel, which is rotating. And for wheel, I am having what, rolling radius to find out the torque as well as the force. Okay. So R, this one is R. You should not confuse this R with this one. This one is radius of gyration, that is K, and this one is R. rolling radius. Okay. So for wheel, I can find moment of inertia. For a vehicle, not only wheel is going to get rotated, other parts also are going to get rotated. Okay. So for that parts, he is giving what? Uh, Mass moment of inertia. It is about 0.733 kg meter square. Okay, kg meter square. It is not shown here. Kg meter square. Transmission efficiency 85%. And total reduction ratio. Total reduction ratio means what? Gear I'm having one ratio, gearbox one reduction, then final drive I'm having one reduction. So this will be taken as what? Capital G. Okay, the capital G is 4.28. And transmission efficiency. And I have to find what? Aerodynamic resistance. Okay, for finding out aerodynamic resistance, he has given the data. The vehicle has a frontal area that is 1.86 meter square and aerodynamic drag coefficient that is what? 0.38. So from this I can calculate what? Aerodynamic force. Okay, based on the speed. So one resistance, aerodynamic resistance I can find. Next, rolling resistance I have to find. No, so rolling resistance will be nothing but rolling coefficient into weight. So you can see the coefficient of rolling resistance is given what? 0.02. So it is like a design of vehicle. So when you are going to work in automotive industry, this parameter and all will be given. That is, they first of all they will give the parameter. That is, you are going to drive on Indian roads. For Indian roads, the coefficient of rolling resistance is this much. So you will find one component, that is rolling resistance, and they will be giving another criteria. That is, what is the speed you are going to drive, and what is the aerodynamic drag coefficient, and frontal area. So from that you will find what? Aerodynamic resistance. And regarding grade, he didn't give. That is, it is assumed that the vehicle is going to travel on level road. Okay, so no grade resistance. Okay, and he has given what? Total gear reduction ratio. That is a gearbox ratio as well as the final drive ratio. Okay, it is given, and mass moment of inertia of the rotating parts is given. Then vehicle weight is given, wheel weight is given, then rolling radius is given. How I am going to use this data? Then engine torque is given. Instead of giving engine power, is giving what? Engine torque. In other words, I can give engine power and speed so that you can find what? Engine torque. Okay. So from this, what you have to do now? The simple thing, what is the acceleration of the vehicle under level road? See, it is mentioned level road. So no need to bother about gradient resistance. So you have to find the acceleration of the vehicle on the level road. Okay. So first of all, you note down this formula. This formula has been taken from the book, and we are not bothering about the derivation of this formula. It is based on the research they have carried out in evaluating the performance. What is the topic we are seeing? Prediction of vehicle performance. How far my vehicle is going to perform. What is the acceleration of the vehicle? So whenever you are going to buy a car, no, the first thing you will be noting what is the power of the engine, what is the acceleration required. Okay, so blindly we can say that is I am not bothering about what engine and all you are going to use, whether what power. I am bothering about what acceleration of the vehicle. That is what is the time duration I'll be having to reach the maximum speed. That is the main criteria that is going to be given by my engine. Okay, so that only in catalog they are providing what? Engine power and speed and engine capacity, that and all it is given. For electric vehicles, no need about this, because already you know electric vehicles are able to provide maximum torque within a short period of time. Okay, so I am bothering about acceleration. Okay, how far I can accelerate my vehicle. So that is known as vehicle performance. When I'm saying prediction of vehicle performance, I have to find out what? Acceleration. Okay, so you can see mass factor, that is using the formula gamma im, that is equal to 1 plus I omega ia eg square. I will be explaining this everything. Okay, iw, I said I omega, no, sorry, you corrected. Iw means what? Moment of inertia of the wheel. Okay, moment of inertia of the wheel. For that, what we have to do now? I need mass of the wheel and radius of gyration of the wheel. Go to the problem. one by one I will explain. Okay, weight of the wheel is given, radius of gyration is given, so I can find what I. Okay, so see, weight of the wheel is given in Newton 244. So divide it by 9.81. Okay, divided by 9.8. So mass of the single wheel. Everything is mass of the single wheel. Let me confirm it is mass of the single wheel or each of the wheel only. Okay, so it is a single wheel only. Okay. So divide it. A k square radius of gyration is given. So you are finding out what 1.61 kilogram meter square. So that is what moment of inertia for a single wheel. Okay. Now I am coming to here. I am putting what R, that is wheel rolling radius. Go to the problem again. The rolling radius is given what 33 centimeter. So you can put 33 centimeter. Okay, 33 centimeter. Now, what is this one now? IEG square. It is moment of inertia of the rotating parts. Moment of inertia of the rotating parts. Okay. So for this calculation only I am putting see radius of gyration is given what 25.4 centimeter. You convert into meter. So see 25.4 10 power minus 2 meter. Okay. And weight of the wheel is 244. So dividing by 9.81 and you are finding moment of inertia of the wheel. Okay. So now we are going to this one. We will be addressing this one later. That is what is the moment of inertia of the engine. That is rotating parts. Okay. So first of all, we will find this one. M R squared roll of the wheel. That is R rolling radius of the wheel. Okay. So first of all, I will say rolling resistance is how much? Sorry, rolling radius is 33 centimeter. If it is meter, 0.3. Okay. What is M? Weight of the vehicle, mass of the vehicle. That is weight divided by G. So you put a capital W. For wheel, you put a small w. Okay. For M, vehicle weight, you put what? Capital W. That is a 21.24 kilonewton. Okay. So see here, I am putting what? 21.24 kilonewton. Convert into Newton. Then only the unit will be satisfied. So 10 power 3 divided by 9.81 into 0.33 square. Okay. So this term is convenient for you. And this term also you got and I got understood about this. And I will be explaining about this one. For this one, he has given the data. See, the moment of inertia of the parts, no, rotating at engine speed. See, 0.733. Okay, 0.733. So you can see IE. IE is nothing but whatever parts which is going to rotate. No, for that only the moment of inertia is 0.733. What is gear ratio? There is not gear ratio. All gears I will be having a ratio, final drive ratio. See, for 4.28. See, 4.28 whole square. G square, no? So, whole square. And here you can see for a single wheel, the moment of inertia is how much? 1.61. I am having how much? 4 wheels. So, I have to multiply by 4. That's all. So from this, I can find what? This mass factor for the vehicle. This concept is very, very important for you. This is the first time you are seeing. It is given in Eisler one. Okay. Mass factor for the vehicle. So here you can see systematically I might have explained inertia of the wheel. Mass moment of inertia of the wheel mk square into 4. This one is equivalent moment of inertia of the rotating parts, gear ratio, vehicle mass. So you can see I am substituting all the values. So second slide, more clear representation is there. Okay. So why I am putting a 216 now? I am dividing it by this one. So I am finding out mass factor how much? 1.08. Okay. Now for this now, you have to find acceleration, and before that we'll be finding tractive effort. This already you might have studied in VDDC. Tractive effort is equal to engine torque multiplied by G, transmission efficiency divided by R. So engine torque, see, it is given. So whenever I am asking about acceleration, I need a tractive effort vehicle speed, because force is equal to mass into acceleration. Okay, so see here, engine torque is how much? 325 Newton meter. Okay. Engine torque 325 Newton meter, and G overall gear ratio 4.28. Transmission efficiency is given R. So find the tractive effort. Okay, there is a for this wheel for this vehicle, no, based on the engine torque, I will be having this tractive effort. Then I have to find the vehicle speed. Already you might have studied the relation between N by V, but here we are using a separate formula. That is why, no, that is we are considering slip. Actually, in ideal case only the rotational speed will be equal to linear speed. In actual case there will be a slip. So you can see in this formula, okay, there is a linear speed is equal to rotational speed into R. What does it mean? No, let me explain. V is equal to R omega. No, listen carefully. V is equal to R omega. That formula only I am modifying like this. V is equal to R omega. R, instead of omega, we'll be putting what? 2 pi n by this one. No, so here we are putting what? N. Okay, and gear ratio, the overall gear ratio, and you have to multiply by 1 minus I. That is a slip. Normally for all the vehicle we are assuming a slip about 3%. Okay, so here you can put 3, and n will be knowing the vehicle engine speed. It is given. Okay. Okay. So you have to work out and try to find this. Okay, let me see whether I have found or not. In the other notes I have written, it is V is equal to nrg1 minus I. Yeah, yeah. See, n is 3,500 rpm. So read the problem. I think during scanning, no, see, the engine develops a torque of 325 Newton meter at, this is not visible. Okay, I didn't copy it properly. So you please note down, engine speed is given 3,500 rpm. Okay, so now here it substitute 3,500 rpm, rolling radius 0.33 g, and 1 minus 3, find out v. Okay, and you convert that v into kilometer per hour. If you are getting 9.88 means it should be in kilometer per hour. So after that you find out the total resistance. So you might have find out Ra and Rr. Okay, so see the first one. That is what you are having, rolling resistance, no, 0.02. You multiply this by weight of the vehicle, and the aerodynamic resistance, uh, A, drag coefficient, and vehicle speed. For that only we are finding what vehicle speed. So you convert into meter per second. That is rho A V square. Okay, that is the aerodynamic coefficient, frontal area. Okay, aerodynamic coefficient into frontal area into speed. Okay, and the density of the air. The density of the air. That is what is the formula? No, rho A V square multiplied by CD. Okay, so 1.2225 into CD is how much? 0.38 into A into V square. That is V. You are finding out here, no? For finding out the aerodynamic resistance only, we are using this formula, vehicle speed. How to find vehicle speed from engine speed. Okay, first you are dividing it by G and multiplying by R. Okay, and slip also we are considering. It is like this one. There is a practically these formulas will be more helpful when you are going to work in a industry. Okay. So you'll be getting aerodynamic resistance one value, rolling resistance one value. Okay, and you will be finding the total resistance C752. You have to work out I have omitted the steps, but in my notebook it is available. After that, I have worked out. If you're having any doubt, you can contact me so that I will give the each value separately. What is RA, RR, and what is V. And you have to understand V. It will be coming around kilometer per hour, 9.8 something. Okay. Now the main formula you have to understand how to find acceleration. Okay. So for finding acceleration, the formula is that is you know that F is equal to ma. So a is equal to F by a. So you listen carefully. For finding acceleration, F is equal to ma. So a is equal to F by a. But in vehicle perspective, you know what you have to do. What is the force? Tractive force minus the summation of the resistance. Okay, so that is the force available for me for propulsion. That is the force available for my acceleration. You should not put F because that F no some portion will be gone for overcoming this resistance. So you have to use that difference F minus R. Okay, so that force will be used for finding out acceleration and divided by M. That is mass of the vehicle. And this one no will not be this one. You have to use the mass factor. So this is the main thing you have to understand. Mass factor should be put for finding out the accurate value of the acceleration. So the value of the acceleration will be how much? 1.2 meter per second square. Okay. So I think you might have understood this. So you copy this formula. First of all, you copy the. No need to write this first. You write this one. Mass factor. Write this and substitute, and later you can work out for finding the mass factor. You copy the next slide, tractive effort and vehicle speed. And finally, write down this formula for acceleration, and you please work it out. And the density of the air will not be given, 1.225 kilogram per meter cube. Okay. So remaining things we will be seeing in the next class. You copy this. Okay. If you're having any doubt, you can ask.